Okay, good. Got it.
Good morning, students.
Good morning, ma'am.
Last week we have completed the unit 1, no? Okay, so we have seen some topics about the direction ratios, direction cosines, and we have seen some problems also. Okay, so almost many topics are there, many formulas are there in the first unit. And if you see your exercise, worked out exercise is there, no, in that many problems are given. Okay, so try to practice all those problems. And last week almost we have seen one theorem, no, that is a line makes angles alpha, beta, gamma, delta with the diagonals of a cube. So prove that cos square alpha plus cos square beta plus cos square gamma plus cos square delta equals to 4/3. Okay, so based on this we have seen that the four diagonals were there: OP, AA dash, BB dash, CC dash. Okay, so for that we have seen the vertices also. So OP means 1/√3, 1/√3, 1/√3. So A dash means minus 1/√3, 1/√3, 1/√3. So like that we have vertices. So based on these vertices also they will ask the means between any two vertices, that is OP or A dash or BB dash or CC dash, they will ask the angle between the edges also. That means if you take OP as one edge and AA dash as another edge, then with the help of the two edges, you will have the vertices, no? So you can take them as A1, B1, C1, A2, B2, C2. So if you you know the formula that cos theta is equals to A1 into A2 plus B1 into B2 plus A3 into B3 divided by under root of A1 square plus B1 square plus C1 square, and also root of A2 square plus B2 square plus C2 square. So in that formula, if you substitute the vertices, then you'll get the angle of that. So you have the question in your textbook. If you'll see the worked out exercises. So model examination question is there, no? So 16th question, if you'll see, find the angle between any two diagonals of a cube. So we have four diagonals are there. So from the four diagonals, if you'll take any two diagonals. Okay. So page number 38. 16th problem in unit 1 only. Find the angle between any two diagonals of a cube. Find the angle between any two diagonals of a. So if you have textbook, so try to open them if you of a cube. So we have four diagonals are there. So from the four diagonals you take any, if you do from the four, if you take any two, so then you will get the same answer, same angle you will get. Okay, so if we consider here the two diagonals of a cube are so if you are taking OP and AA dash, so OP equals to 1/√3, 1/√3, 1/√3, and AA dash is equals to minus 1/√3, 1/√3, 1/√3. Okay, so the angle between the any two diagonals of a cube, we have the formula is cos theta is equals to, if you consider them as A1, A2, A1, B1, C1, and this is A2, B2, C2. So A1 into A2 plus B1 into B2 plus C1 into C2 by under root of plus B1 square plus C1 square under root of A2 square plus B2 square plus C2 square. Okay, this is the formula. So when you consider them, here A1 is this one and A2 is this one. That is 1/√3 into minus 1/√3 plus 1/√3 into 1/√3 plus last 1 by root 3 into 1 by root 3 divided by under root of 1 by root 3 whole square plus 1 by root 3 whole square plus 1 by root 3 whole square. Okay. And for this one, it is minus 1 by root 3 whole square plus 1 by root 3 whole square plus 1 by root 3 whole square. So cos theta is equals to 1 by, this is minus sign you have, this is the plus sign you have. So you will get minus 1 by 3, root 3 into root 3 is 3 plus 1 by root 1 by 3. Next last one is 1 by 3. Divided by, if you do the square root of this one, you will get 1 by 3 plus 1 by 3 plus 1 by 3. That is 3 by 3. So you get root 1 and this is also root 1. And here minus 1 by 3 and plus 1 by 3 both will get cancelled. So only 1 by 3 will be there. And in the denominator, root 1 into root 1 is 1. So that whatever the cos theta you are getting angle, that is 1 by 3. So theta is equals to cos inverse of 1 by 3. Okay. So if you will get the cos, whatever the cos theta value as 1 by 2 or root 3 by 2 or 1 by root 2 or 0 like that, anything means you can find the theta values. So for theta you have 0 degrees and also 30 degrees we have. After that 45, 60, 90, 180 we have 270, 360 degrees. So if for those any theta values if you get, you can find the angle that one. So here 1 by 3 you will not get for any theta value. So just keep like that only. Theta equals to cos inverse of 1 by 3. Okay. So like this, you have to find the angle between any two diagonals of a cube. Even in the question, if they give any points also. Here 1 point and here 1 coordinate. 2 points, if they give same formula you have to apply and you have to find the angle between them. Okay. So this concept is there, and another one is one more concept you have in first unit. So this is also you may get for 10 marks question. Same theorem like you have. So page number 32. So if you have textbook, so try to open that and see page number 32. You have proved that the two lines whose direction cosines are given by the relations AL plus BM plus CN equals to 0 and MN plus NL plus LM equals to 0. Okay. So when two direction cosines lines are given, so you have the condition for perpendicularity and also for parallel. So when it is perpendicular, you will have the condition A inverse plus B inverse plus C inverse equals to 0. And if they are parallel, then root of A plus or minus root of B plus or minus root C equals to 0. Okay. So to solve this one, the equations, whatever the direction cosines are given, two equations, in that you have to eliminate from the first equation any one, that is either L or M or N. Okay. You take out as L common and you consider one relation here. So you will get N equals to minus of AL plus BM by C. So then substitute this N value in the second equation. Okay. So when you substitute second value, that is N value in the second equation, you will get one quadratic equation. So here the quadratic equation is in the form of A L square by M square plus 1 by M, A plus B minus C plus B equals to 0. That is in the form of AX square plus BX plus C equals to 0. So by that you consider that one. So eliminating M and N. So this is the equation for when you are taking N as common. When you will take L, you will get another equation. When you will take M, you will get another equation. So when you will consider all those three equations, with the help of that, whatever the proof you have, just go through this proof. So you may have the chance of getting the 10 marks question for this one. Or else, based on this topic only, you have the problems will be there. Okay. So any two direction cosine lines will be given and you will ask to find the direction ratios of that one. Okay. So we'll see one problem on that one. So whatever the this problem 32 and 32 page number solution is there. So you try to practice that one. Okay. So we'll see one problem on same this one only. Whatever the problem you have on that only, you have the problems. If you see on page number 39, it is 20 is there no question 20 ABC problems. So these are related to that problem. That is actually it is like a theorem. Okay. So from that theorem, you have the problems how to solve. Okay. So page number 20, page number 39, question number 20, the direction on cosines of two lines are connected by the following equations. So find them. So we'll see one, and we if I'll tell one, you can solve the other problems. So the direction cosines given are L plus M plus N. So after this problem, we'll go to the second unit. So page number 39, 20 question. Just I am writing the here direction cosines and we'll solve the problem. Okay. So whatever the question is there, you write that one. So the given one is L plus M plus N equals to 0. And next to 2LM plus 2LN minus Mn equals to 0. So that is the C1 we have. So this you put it as equation 1 and equation. So from equation 1, so if you take L common, what you will get? So L equals to minus M minus N. Okay. So substitute this L value in 2. So you will get it as 2 into minus M minus N, and we have M here, plus 2 minus M minus N we have, minus Mn equals to 0. Now if you simplify this one, you will get it as minus 2M square minus 2Mn minus 2Mn minus 2M square minus Mn equals to 0. Okay. So minus 2M square, 2Mn, 4 minus 5M. Okay. If we take out minus common, what you'll get here? 2M square minus, plus 5Mn plus 2n square equals to 0. Okay. So now you do the factorization of this one. So 2m square into 2n square. Okay. So if you multiply both of them, you will get 4m square n square. So 4m square n square, in between you have to get 5mn. So factorization you will do, no? So when you do multiplication of two numbers, you have to get this one a and c value. When you do the addition of those numbers, you have to get the middle part here. So 4 is there. So 4mn plus mn, you will get this one, and 4mn into 4, just mn means you will get 4m square n square. Okay. So it is 2m square plus 4mn plus mn plus 2n square equals to 0. Okay. When you add this, you will get the middle part. When you do the multiplication of this one, you will get this one. Okay. So if you will take 2m common, m plus 2n you will get. And here if you will take n common, m plus 2n. So when you equate it to 0, you will get 2m plus n. Next m plus 2n equals to 0. Okay. So here we if we get do the m value, so you will get it as 2m plus n equals to 0, one case. Another one is m plus 2n equals to 0. So from this you will get 2m equals to minus n, implies m equals to minus n by 2, and here m equals to minus 2n. Okay. So for two factors, you will get the two values. First value is m equals to minus n by 2, and second value is m equals to minus 2n. So whatever the m value is there, minus n by 2, you put in the equation 1. So then you will get one relation of L, m and n. So that L, m and values are here, our direction cosines. Okay. Here if I write, you'll yeah. Okay, substitute first case one is m equals to minus n by 2. Okay, substitute m value in 1. So you will get it as L minus n by 2 plus n. Okay, equals to 0. So L minus, this is minus n, or else you take that side, it will be n by 2 minus n. So it is equals to n minus 2n by 2, that is minus n by 2. Okay. So, but what is our minus n by 2 from here? Case 1, it is m value. So you can write this as L is equals to minus n by 2, but this minus n by 2 is equals to m. So we got relation now here. L equals to minus n by 2 equals to m. This we can write it as LMN. So to write in order, it is L is equals to m equals to minus n by 2 here. So in the denominator you have nothing, means you can take it as 1, that is. So whatever in the denominator you have 1, 1, and this is minus 2. You take that in the denominator, minus 2. These are the direction ratios. We have the relation L by A equals to M by B equals to N by C. So whenever to find the element values, we have the formula. I have told that one, the relation between direction cosines and direction ratios is L equals to plus or minus, L equals to plus or minus A by under root of A square plus B square plus C square. So by that you will get the direction ratios here. So here L equals to, so whatever in the denominator is there, that is 1 by under root of 1 square plus 1 square plus minus 2 whole square. Okay. So you will get 1 by under root of 1 plus 4. So it is 1 by root 6. So same similarly you can find for m is also equals to 1 by root 6 and n is equals to minus 2 by root 6. Okay. So the direction ratios are L comma m comma n. No, first L is 1 by root 6, next 1 by root 6, next minus 2 by root 6. Okay. So this is the procedure of finding the values here. So this is only the values for when m equals to minus n by 2. Similarly, we have to find when the case m equals to minus 2n. Okay. Here you can write the direction ratios are 1 comma 1 comma minus 2. Okay. So when m equals to minus 2n, so first equation is L plus m plus n equals to 0. So case 2, m equals to minus 2n. Okay. So substitute m in 1. So you will get L plus m value is minus 2n and plus n equals to 0. So L minus n equals to 0 implies L equals to n. Okay. So from here you take n is equals to minus m by 2. Okay. You can write here n value as minus m by 2. Now in place of n, this is equals to minus m by 2. So when you write in order, L is equals to m by minus 2 equals to n by, that is 1, that is 1 here. So the direction ratios are 1 minus 2, 1. Okay, just the interchange is there. So from first one you can see in the denominator you will get same root 6. 1 plus 4 plus 1. So it is a 6. So you can write L equals to, I'm writing here directly. So m is equals to minus 2 by root 6. Okay. So L comma M values are 1 by root 6 minus 2 by root 6. So for case 1, we have this one, and for case 2, this one. Okay. At last, we can write LMN equals to, so both combined you write that one and this one. Okay. That is, these are the direction cosines of the given one. So 1 by root 6, 1 by root 6, 1 minus 2 by root 6. Next 1 by root 6 minus 2 by root 6 minus 1 by root 6. Okay. So like this, you have to solve the problem when direction cosines are given as a lines. So you have in 20 problem 3, 1, 2, 3 problems are there, and even 18th question also you have that one. Two cosines line equations are given, and you have to show that they are perpendicular to each other. Okay. So this one topic we have left in the first unit. So today we have covered this one. So any problem given on this, so try to solve this one. And one more is in this, it is 21 question is there, no? A line makes making angles alpha, beta, gamma with the coordinate axis. Then show that sine square alpha plus sine square beta plus sine square gamma equals to 2. Okay. So in your textbook you have cos square is that is relation is there, no? So and from the definition of direction cosines, starting I have told, no, direction cosines. So in that we have seen that from the positive direction of x, y, z axis. So whatever the x, y, z axis lines were there, no, 3 lines. So they were making the angles of alpha, beta, gamma, and they are made the cosine angle. That's why we call them as cos alpha, cos beta, and cos gamma. So from that you have the relation is cos square alpha plus cos square beta plus cos square gamma equals to 1. Okay. So from that relation you will get that, and we need here in the question is sine square we need. So cos square we can convert into sine square, no? That is in place of cos square you can substitute it as 1 minus sine square. So then you will get the values here. So the question is 21 question page number 39. So we have to show that sine square alpha plus sine square beta plus sine square gamma equals to 2. Okay. So this is the question. It is page number 39, 29, 21 question. Okay. So here, so first you write that one. If alpha comma beta comma gamma are the angles of the line which makes with positive direction of x comma y comma z axis, then cos alpha, cos beta, cos gamma are called the direction cosines of the line. So from this we have the condition is cos square alpha plus cos square beta plus cos square gamma equals to 1. Okay. So cos square alpha you write it as 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma equals to 1. We know that sine square alpha plus cos square alpha equals to 1. So from that we can convert cos square alpha as 1 minus sine square. Okay. So here 1, 2, 3 ones are there. It is 3 minus sine square alpha minus sine square beta minus sine square gamma equals to 1. So when you take this 3 that side, you will get minus sine square alpha minus sine square beta minus sine square gamma equals to minus 2. Okay. So we need sine square, that is plus sign is there. If you take minus common here, you will get it as sine square alpha plus sine square beta plus sine square gamma equals to, here minus 2 minus both will get cancelled. So therefore you will get sine square alpha plus sine square beta plus sine square gamma equals to 2. Okay. So like this you have to solve the problem. This is the 5 marks question you will have. Okay. So by this we are completing the unit 1. So whatever the MEQ questions are there in your textbook and worked out exercises are there and check your progress are there. So try to solve all those problems. Okay, now we'll go to the second unit. And the second unit we have the equation of plane. So while telling the introduction, I have told what is the general equation of the plane. That is ax plus by plus cz plus d equals to 0 is called as a general equation of the plane. So unit 2, the plane and various forms of the equation of a plane. The plane and various forms of the equation of plane. So this is our second unit we have. So first we have the general equation of the plane, that is the general equation of plane. Okay. So the general equation of the plane is ax plus by plus cz plus d equals to 0. Whenever this equation of plane, if it passes through the origin, you will get that this here d value is 0. Okay. If it passes through origin. Then we have ax plus by plus cz equals to 0. Okay. So this is our general equation. Next we have normal equation of the plane. Equation of plane. It is Lx plus My plus Nz equals to P. Okay. So here where Lmn are the direction cosines here. Okay. So Lx plus My plus Nz equals to P is called as a normal form of the equation of the plane. So problem will be asked on conversion of the whatever the general equation of the plane is there into normal form of the equation of the plane. Okay. So with the help of ax plus by plus cz plus d equals to 0, we have to find here the relation we have no direction cosines and direction ratios. That is L equals to a by under root of a square plus b square plus c square. So like that you have to find Lmn values, and if you substitute in this equation, you will get the equation of the normal form. Okay. So that problem you have. So before that, first is the general equation of the plane. After that, while the introduction, I have told even the equation of any plane passing through. Equation of, this is the important one. You may get even objective type question also on this directly. If you substitute the given point in the equation, you will get the equation of the plane. Okay. Equation of any plane passing through x1, y1, z1, passing through the point is of the form that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. Okay. So the problem will be asked for only 1 point also, or else in some cases they will ask 3 points will be given. Okay. 3 points you have to substitute in this equation. So that is first x1, y1, z1, you will get one equation. In that equation, you substitute the second point and substitute the third point. Then after simplifying the second and third equation, you will get the ABC values. If you substitute that ABC values here, you will get the equation of the plane. So this is the 5 marks problem you will ask compulsory, or else in the objective type, they will give one point, and with the help of this equation, you have to find the equation of the plane. Okay, so suppose if you think 1 2 3 points are given, one x1 is 1, y1 is 2, and z1 is 3, then you substitute here. So a into x minus 1, b into y minus 2 plus c into z minus 3. If you simplify that, you will get this as ax plus by plus cz, and some constant value you will get. So okay, that is the equation of the plane. So this same formula you will apply for finding the equation of the plane with the 3 points also. Okay, so this is the many formulas are there in your textbook for the equation of the plane. If you have textbook, see the page number 45. There you have 2.3.3. It is the transformation to the normal form. So whatever the general equation is there, this general equation to convert into Lx plus My plus so Lx plus My plus Mz equals to P. Okay, so this one to convert into this one, we need to find the procedure, that is A, B, C values. From the given problem, you can see what are A, B, C problems. So from that, if you substitute L value, M value, N value. So L, we know that it is equals to plus or minus A by under root of A square plus B square plus C square. Okay, so if you see 45 page number, first general equation is given. Next you have the normal form is there. So from 1 and 2, we know that the relation between direction cosines and direction ratios is A by L equals to B by M equals to C by M. Here constant values in the first equation is minus D. So if we'll take out that one to the right hand side, then you will get it as minus D. So minus D by P. So it is equals to, we will equate it to root of whatever A square plus B square plus C square is there by under root of L square plus M square plus N square. We know that L square plus M square plus N square value is 1. So you will have only under root of A square plus B square. So from that you will get L value, M value and N value. So here when you compare this one and this one, you will get last constant also, that is P is equals to minus or plus D under root of A square plus B square plus C square. Okay, P is always positive here, so it is on the right hand side, no? And if you see the conditions here, last one, that is A under root of sigma A square into X plus B under root of sigma A square into Y plus C under root of sigma A square. If you see last one, if D is negative, means in the given problem, if D is negative, the last value will be minus D under root of sigma A square. If D value is positive in the given question, then you will get the positive D. Okay, you remember that one here. So while solving the problem, so if you get their negative value, you put it as minus D by under root of sigma A square. If it is a negative value, you put it as negative value. Okay, so on this also conversion, you will get the problem. And after that, you have notice there the direction ratios of the normal form to the plane is A comma B comma C are the direction ratios here. And second one is the important note, that is to find the perpendicular distance from the origin between the plane. Okay, origin to the plane. So origin means you will be 0 comma 0 comma 0, and the plane you have ax plus by plus cz plus d equals to 0. So here when you multiply both of them, so you will get it as all these xyz values will become 0, only d will be left. So that's why the formula is perpendicular distance formula is d by under root of a square plus b square plus c square. So we have now between any 2 points, that is A into A1 plus B into B1 plus C into C1. Here ABC values are 0, no? Origin means 0 comma 0 comma 0. And here for the plane equation A, B, C. When you multiply them, you will get all zeros. Only D will be left here. So D under root of this one. Okay. So this is the formula. You remember this one. They may ask even in objective type. Okay. So on this, whatever the topics are there, on that you have the problems are there. So same, if the two plane equations are given, then the angle between the any two plane equations is last, whatever the first unit we have seen, that one same. That is a1x plus b1y plus c1z plus d1 equals to 0. And if you have a2x plus b2y plus c2z plus d2 equals to 0, then angle between these two plane equations is angle between two planes will represent as cos theta is equals to a1 into a2 plus b1 into b2 plus c1 into c2 by under root of a1 square plus b1 square plus c1 square a2 square plus b2 square plus c2 square. Okay, same whatever we have seen in the first unit, say that one only will have, and through this angle we will have the condition of perpendicularity. So perpendicularity means whatever the numerator is there, that is equals to 0. That is a1 into a2 plus b1 into b2 plus c1 into c2 equals to 0. So whenever two planes are given in the problem and he is asking to find the condition of perpendicularity, so then you can compare the direction ratios a1, a2, b1, b2 and c1, c2. And when you equate it to 0, you can show that they are perpendicular to each other. So this is the condition of perpendicularity. And condition of parallelism is a1 by a2
sin 0
equals to b1 by b2 equals to c1 by c2. Okay, next page if you'll see 48 page number, you have the condition of perpendicularity and condition of parallel. Okay, so these two are the objective questions. So they may ask that when it is the angle between the two planes, what is the condition of perpendicularity and what is the condition of parallelism. Okay, so example you have on that. So if you see the check your progress, you have one problem. Find the angle between the planes 3x minus 4y plus 5z equals to. So based on these all, we'll see the problems. So first one is general equation we have. Second one is if it is passes through the origin. So what is the equation? Next, what is the normal form of the equation? Next, equation of any plane passing through the point. And the third one is we have the if two planes are given, how to find the angle between that. And another one is conversion of general form of the plane into normal form. Okay. So try to all of you means by heart the formulas. So formulas, even if they may ask for the objective type question, multiple choice also they will ask. And you have to remember them for solving the problems. So to find the angle between the planes, we have find the angle between the planes. Find the angle between the planes 3x minus 4y plus 5z equals to 0 and 2x minus y minus 2z equals to 5z. Okay, so here you compare what are the a1, a2, a3 values and also what are a2, b2 and c2 values. Then if you substitute them in the formula, then you will get the angle between them. Okay, so in the solution, so what are a1, a2, a3 values here? So d1 value we are not having here, and from the second plane we have a2 equals to 2, b2 equals to -1 and c2 equals to -2, and actually d2 is equals to 5. But in the angle formula we are not having in the d value, no. So a1 a2 plus b1 b2 plus c1 c2 we have, but we are not having the here. Why? Because numerator we have the condition of perpendicularity. So theta is the angle, whatever the steps you have in your textbook example, try to that one. Theta is the angle between the two planes, angle between the two given planes. So then cos theta is equals to, so write the formula while writing in the examination. Okay, I'm not writing here formula, just to multiply this one. This is 3 into 2. Next we have minus 4 into minus 1. Next 5 into minus 2 divided by under root of 3 square plus minus 4 square plus 5 square and under root of 2 square plus minus 1 square plus minus 2 whole square. Okay, so this is 3 to the 6, minus into minus plus 4, in the denominator minus 10. So here numerator you are getting 0 now. So if you want, you can simplify this, or else you can put 0 by this one same, then the value is 0 is here. So it is 3 square 9 plus 4 square is 16 plus 25. So 25 plus 25 means root 50. So you'll get 5 root 2. And next here 2 square is 4. 2 square is 4. 4 plus 4 is 8. 8 plus 1 is 9. So you'll get here it is 3. So actually numerator is 0. 0 by this we have 5 root 2 into 3. So this is equals to 0 is here. So cos theta is equals to 0. Implies theta equals to cos inverse of 0 here. So for what value of 0 you will get theta angle here. So when actually cos 0 value is 1. But we need the here 0 value. So you'll get for cos 90 degrees. Okay. So we can write this as cos inverse of pi by 2. Okay. This cos and cos inverse. So trigonometric function and inverse trigonometric function both will get cancelled. So here the angle is pi by 2. Okay. So here the theta value is pi by 2. So for cases whenever you have the angles, you will get the theta value. But when you can't find the angles, directly you keep like that only. Okay. So like this, you have to solve when two planes are given to find the angle between the planes. Okay. So next we'll see the any points. If 3 points are given, how to find the angle equation of the plane. So 1 point is given means directly we can write that one. If you substitute in the formula, that is a into x minus x1 plus b into y minus y1, you can do that one. Okay, the problem will be like this. Find the plane passing through the points 1, 1, 0. And next we have minus 2, 2, minus 1 and 1, 2, 1. Okay. So we have to find the equation of the plane. So with the help of this 3 equation, 3 points we have. Okay. So first you write any equation of the plane passing through the first point. So you can put here the points name here. That is, let P equals to 1, 1, 0 and Q equals to minus 2, minus 1 and R equals to 1, 2, 1. Okay. So any plane passing through the point, we have equation through the point x1, y1, z1 is we have a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. Okay. So now save any plane passing through the point. What is our point P? that is 1, 1, 0 is, so A into x minus, this is x1, y1, z1, okay. So x1 is -1 plus b into y minus y1, 1 plus c into z minus 0. So you can write it as only cz, okay, equals to 0. So you put this as equation 1, okay. Next, you can write here, that is equation 1 passes through, equation 1 passes through Q and R, okay. So we will get this as, that means in place of here x, in place of x, y, z, you substitute the q value, that is -2, 2, -1, and after that 1, 2, 1. You will get two equations, okay. So you will get it as a into, here x is -2, -1 plus b into y is 2, 2 -1 plus c into -1 equals to 0. You simplify this, -1 -2 is -3, so it is -3a. Next 2 -1 is 1, so b. Next we have -c equals to 0. So you put this as equation 2. Next one through r, what you'll get? A into, so 1 -1 plus b into 2 -1 plus c into z value is 1. So you will get it as, this is a value will become 0, 1 -1 means 0. So this is b plus c equals to 0. So this is the third one, okay. You can solve 2 and 3 and we can find ABC values through normal method, solving of 2 and 3, or else in this you are not having a value. So but if you have ABC values, and here with the help of normal equations you can solve these two, or else with the help of the cross multiplication method, okay, you can solve and you can find what are ABC values, okay, by solving 2 and 3. Solving 2 and 3 by cross multiplication method. Okay. So you are able to see in the down also. So I am writing here. So by finding the cross multiplication method means we have to write here the coefficient of B, C, A, and after that again B. So similarly for third equation also. So the coefficient of B is here 1. After that C is -1. And after that A is -3 and again B. So 1. So here B is 1, C is 1, A value is 0 here. Next again 1. So if you cross multiply this, then you will get A divided by 1 plus 1 equals to B divided by, this is 0, minus into minus plus 3 equals to C divided by, this is -3 and this is 0. So it is -3. Okay. So you will get ABC values as, that is A by 2, B by 3 equals to C by -3. So here therefore A equals to 2, B equals to 3 and C equals to -3 here. Now substitute these A, B, C values in equation 1. Substitute A comma B comma C in 1. Then we get that is 2 into x minus 1 plus 3 into y minus 1 minus 3z equals to 0. If you simplify this, 2x plus 3y minus 3z and constant is here -2 -3. So we will get it as -5 equals to 0. Okay. So this is the required equation of the plane when it is passing through the 3 points. Okay. So at last you can write, this is the equation of the plane which is passing through 3 points. So whenever like these 3 points are given, so first you substitute that point in the equation of the any equation of the plane with respective of a point, we have no this one a into x minus x1 b into this one. So after that, whatever this equation of plane is there, it is passing through the other 2 points. Okay, so whenever it is passing other 2 points, those points will become x, y, z. So in place of x, y, z, you substitute the q value and also then substitute the r value, then you will get 2 equations. So whenever you will get the 2 equations, so here you are not having x, y, z, only ABC are there. So when you solve 2 and 3, you will get ABC values. So that direction ratios, whatever ABC are there, if you solve through the cross multiplication method, you will get the values. If you substitute that values in the given, whatever the first equation we got, then you will get the equation of the plane. Okay. Same procedure you will have when one point is given, okay, and 2 plane equations will be given in the question. Okay, so only 1 point and 2 plane equations. So with the help of the 3 points, you are finding the here 3 equations. But in other problem, they will give 1 point, so you will get this one, and 2 equations will be given. So when 2 equations are given, from the 2 equations you find ABC values. Same procedure, but there already plane equations will be given in the problem. Okay, so the problems are find the equation of the plane when they are passing through the point. See page number 65, you have 5th problem. Obtain the equation of the plane passing through the point -1, 3, 2 and perpendicular to the 2 planes. So 2 planes will be given and 1 point will be given. The same procedure will be there here. So that point you substitute, you get equation 1. So perpendicular to the plane equation means here instead of x, y, z, you have to substitute them as ABC. Okay. So that is a plus 2b plus 3c equals to 5 and 3a plus 3b plus 2c equals to 8. So when you solve those 2 equations, you will get ABC, and if you substitute them in 1, you will get the equation of the plane. So the same procedure will be there when 1 point is given and 2 equations are given or 3 points are given. Okay. So this is one problem. Next we have on conversion transform of the general equation into, that is a normal form. We have no Lx plus My plus Ny equals to P. So after, in your textbook, after giving each and every formula, they have given the example problems and also check your progress is given. Okay, so try to solve those all. See, another one we have, that is find the direction cosines of the normal to the plane. Find the, so these all are 5 marks questions. Find the direction cosines so we need to find the direction cosines here. Okay, so this is in the form of the ax plus by plus cz. So dy, so compare this one with, compare the given equation with ax plus by plus cz plus d equals to 0. So when you compare them, what you will get the values here? What is a value? 2 and b is -3 and c is 6 you will get, and d, if you take this inside, you will get -7. That is -7 equals to 0. So d equals to -7, it is less than 0. Okay. So now we have to find the direction cosines. So direction cosines means what? So direction cosines are L equals to a by under root. We have formula no, plus or minus a by under root of a square plus b square plus c square. So we have here a is 2 by under root of 2 whole square minus 3 whole square plus, so 2 by, this is 4 This is 9 and this is 36. So 36, 4, 40, 49 means you will get here 7. Okay. Similarly, we will get m is equals to, that is minus 3 by roots, that is 7. Next, n is equals to 6 by 7. Okay. So you can write here direction cosines are, so first L is this one, m is minus 3 by 7, this is 6 by 7. Okay. Like this, when equation of the plane is given, through that you can find the direction cosines. Okay. So this is the procedure for that one. Next we have conversion of, that is reduce the equation reduce the equation 2x minus 6y plus 3z minus 21 equals to 0 of a plane into normal form. Okay. So this is the plane equation, that is, it is ax plus by plus cz plus d equals to 0. Now you have to this one reduce into normal form. Normal form is lx plus my plus nz equals to p. So compare the given equation with the equation of the plane ax plus by plus cz plus d equals to 0, and you find what are ABC values. So sentences are there in your problem, in the example problems you have. So try to write that one. That is, the given equation is two x minus 6y plus 3z minus 21 equals to 0. Okay, it is in the form of ax plus by plus cz plus d equals to 0. Okay, so where we have, what is a value? 2, b is minus 6, c is 3 and d is minus 21. It is less than 0. Okay, so next it can be reduced into normal form. It can be and what is the form? Lx plus my plus nz equals to p. Okay, so where we have L equals to plus or minus a by under root of sigma a square. So here under root of sigma a square means you are expanding this one, that is same, a square plus b square plus c square. Okay, so m equals to plus or minus b by under root of sigma. Next we have n equals to plus or minus c by under root of sigma a square. And p is equals to, so here negative value, no? So the formula is minus d by under root of sigma a square. So if here positive is there means here you will get the positive value. Okay. So we need to find L, M, N values. So when you substitute A, B, C, D values in this one, you will get the values, that is L is equals to A is 2, 2 by under root of 2 square is 4, 6 square is 36 plus 9. It is equals to 2 by 7. Okay, 40, 49, 7. Similarly, you will get M is equals to minus 6 by 7. N is equals to 3 by 7. We need P value. P is equals to minus D. So minus 21 is there. Minus of minus means plus 21. By denominator, you will get 7. So we'll get the answer as 3. Okay. So we got LMN and P value. So substitute in that one. Therefore, normal form of the equation. Therefore, the normal form of the given equation of the plane is, okay, you are able to see, no? So now what is our L? L is 2 by 7 into X, and M is minus 6 by 7 into Y plus 3 by 7 into Z, and we need P, no? It is equals to 3. Okay, so this is the equation of the general form we are converting into normal form. So like this, we have to find this one. So example problems are also there on this one. You try to solve those then. See, after angle between the planes, next we have the concept of length of the perpendicular from a point to the plane. Okay, 54 page number you have. This is the important one. On this you will get the 10 marks problem. You will have page number 54. Corollary is there, no? The length of the perpendicular from the point x1, y1, z1 to the plane is. Okay. So for each, after each and every formula, you have one example problem is there and one check your progressive problem is there. Okay, try to solve those all problems. And this is the important formula, that is the length of perpendicular from the point x1, y1, z1 to the plane ax plus by plus, okay, this is plus or minus a into x1 plus b into y1 plus c into z1 by okay. So this is the perpendicular from the point to the plane equation. So a into whatever the point is there, x1 plus b into y1 plus c into z1 plus d under root of a square plus b square plus c square. So with the help of this, we can find two plane equations will be given. So from the two plane equations, we can find the perpendicular from that point. And when you, this is plus or minus sign is there, no? When you add that, you'll get one equation. When you do the subtraction, that you'll get another equation. Then we have to find the angle between those two planes, and you have to see whether theta is making the acute angle or it is making the obtuse angle. So that problem will be there for the 10 marks question. Why? Because you will get 4 plane equations. From the 4 plane equations, you have to take any 2 plane equations and you have to find the angle. And after finding the angle, you have to check whether the angle is making a acute angle or obtuse angle. Okay. So on the page number 55, you have the problem is given. Find the length of the perpendicular of the point from the plane. So here the point is given 1, 1, 4. And the equation of the plane is 3x minus 6y plus 2z plus 11 equals to 0. So just the thing is, if you substitute in the formula, what will happen? It is plus or minus a into, and see here. So try to write the problem. Just I am writing here point and also plane equation. Okay. So from plane equation, what we have? A value is 3, B value is minus 6, and C value is 2, and D value is 11. Okay. And x1, y1 value is x1 is 1, y1 is 1, and z1 is 4. Okay. So substitute in, if you will take this as equation 1, or substitute in 1, what you will get? So the you write the sentence, the perpendicular distance the length of perpendicular from the point 1 comma 1 comma 4 to the plane 3x minus 6y plus 2z plus 11 equals to 0 is, so you will get plus or minus a into x1. So a into x1 means 3 into 1 plus minus 6 into 1 plus 2 into 4, and our d is plus 11 by under root of ABC squares. So 3 square. So it is equals to 3 minus 6 plus 8 plus 11 by under root of, this is 9 plus 36 plus 4. So we get 49, and this is so minus 6, 8 means we'll get 2, 2, 15, 16 by 7. Okay, so this is the length of the perpendicular from the point to the plane. So like this, all the formulas. So here the remembering of the formulas is very important. So if you remember the formulas of each and every one, so you can solve the problems. Okay, so next we have 55 page number, distance between two parallel planes. Okay, two planes are given. Parallel means here the planes you will have only the difference of here last value, constant value is there, no? There you will have the difference, that is ax plus by plus cz plus d1 equals to 0. Then ax plus by plus cz plus d2 equals to 0. Okay, so only the difference will be only the constant value, that is d1 and d2 will be different, but here a b c values and here also a b c values both will be same. Okay, then you have the formula is, that is d1 minus d2. Why? Because these are same, no? X, Y, Z coefficients are same, only d1 d2 differ. So the formula is d1 minus d2 under root of a square plus b square plus c square. And here one note is there, the equation of any plane parallel to the plane ax plus by plus cz plus d equals to 0 is ax plus by plus cz plus lambda equals to 0. So this also they will ask one, even you may get the, that is a objective type, direct they will give what is the equation of the plane when two planes are parallel to each other. So this problem you have. So actually the problem will be there for the equation of the plane parallel is also there. So perpendicular means you have to do the cross multiplication of, that is a1 into both, you have to do the multiplication. When it is a parallel means just instead of d you have to substitute the lambda value and you have to find that one. And even on distance between the two planes, so you have the problem, example problem is there, and also exercise you have. Okay, try to solve them. So after the system of planes is there, on that you are not having any problems. So try to solve the worked out exercises. See page number 59, you have the question is there, no? Find the equation of the plane which passes through the point 3 comma minus 3 comma 1 and is parallel to the plane. Okay, if it passes through the point means you need to find with the help of a into a into x minus x1 is there, no? So in that you have to substitute that one, and if it is passing means you have to substitute the lambda. Okay, sometimes directly one plane equation they will give and they'll ask to find the equation of the plane which is parallel to that one. That means instead of lambda, whatever d value is there in the given problem, there you have to substitute the lambda, then you will get the answer. So find the equation of the plane which passes through the point which passes through, you have 3 minus 3 1 and parallel to plane is 2x plus 3y plus 5z plus 6 equals to 0. So any plane passing through the point means any plane passing through 3 minus 3, 1 is a into x minus 3, y plus 3 plus c into z minus 1 equals to 0. So you'll get ax plus by plus cz. Next we have minus 3a plus 3b minus c. Okay. So for finding the parallel of this one, we need to find only here the any plane parallel to the given plane will be any plane parallel to the given plane is given plane 2x plus 3y plus 5z plus 6 equals to 0 is what you have formula 2x plus 3y plus 5z plus lambda equals to 0. Okay. So same A, B, C values here also A, B, C values will be same, only the differ will be D value. So then only the two, whatever the planes are there, they are parallel to each other. So okay, the point 3 comma minus 3 comma 1 is passing through 1. Then we get, so if you substitute the x, y, z values, that is 2 into 3 plus 3 into minus 3 plus 5 into 1 plus lambda. So we need the lambda value. So for finding the lambda value, you substitute the point here. So 6 minus 9 plus 5 plus lambda equals to 0. That means 6 minus 9 means here minus 3. Minus 3 plus 2 means you will get lambda value equals to minus 2. So if you substitute lambda in 1, so you will get the equation is 2x plus 3y plus 5z minus 2 equals to 0. So here the two planes are parallel to each other means only the different, there will be difference between only D values. Okay. A, B, C values will be same, only the difference will be the D value. Okay, it passes through now. So it is passing through the distance of minus 2. Here it is passing through the distance of minus, that is 6. Okay. 6. So whenever a plane, to find the equation of the plane which passes through the point and parallel to this one means you take formula, just now I have told no, the formula for parallel to the equation of the plane means just you put the lambda in place of D. Then you substitute the point in the given plane equation, you will get lambda. If you substitute that lambda here, you will get the equation of the plane which is parallel. So perpendicular means just a slight difference will be there. First, with the help of the point, you have to find, just before I have told no, a into x minus x1 plus b into y minus y1. There you will get one equation. Perpendicular means you will get two equations. So if you solve them, you will get a ABC values, and if you substitute them, you will get the equation of the plane. Okay. So C is 59, page number 60 and 61, all the example and exercise problems. So by this, we are completing the second unit. So tomorrow we'll start the third unit. Third unit is a bisectors of the angles between two planes and two sides of a plane. Okay. So in this bisectors, you will have the 10 marks question, and other topics, whatever are there, they are the 5 marks questions you will get. So tomorrow we may complete the block 1. So next 2 classes are only there. So we'll try to see them. So if you have, do you know that any extension of classes is there? Okay.
Ma'am, I think on 26 and 27 March also classes are there, ma'am.
26 and 27. Actually, 12 classes were the schedule, but already for you, the examination schedule is given, no?
Yes, ma'am.
Okay, that's why they have told to take only the 6 classes for the elective one. That is next Sunday we have no 12th and 13th.
Yes, ma'am.
So for you, any timetable is given, 26th and 27th?
Ma'am, in the Telegram channel, they have given like that, ma'am.
Okay, I will confirm once. Okay, if again 2 more classes are there, means we'll try to complete the block 3 also.
Yes, ma'am.
So only if next Sunday it is the last class, means we'll see the important 10 marks questions. That is, I have told no shortest distance is there. Means without taking the any units directly, what are the important problems I will tell. Okay,
Yes, ma'am.
I'll mention the unit from that which you are getting for the 10 marks question. So we'll go through them. So try to solve those all problems. So 3D is only the making the practice of the problems. In these theorems are also not there. So remember the formulas and try to solve them.
Yes, ma'am.
Okay. So tomorrow we'll see the class. Okay. Bye, students.
Thank you, ma'am.